Hi, myself, professor, working in working at KS Rangasamy College of Technology, Tiruchengood. Here I talk about some small introduction about nanoscience and nanotechnology. So, so here we talk about what is nanoparticle and what is the size of nanoparticle and what is nanoscience and nanotechnology. So what are the hidden opportunities in the area of nano dimension, and also what are the techniques are used to characterize the nanoparticle, and basically what is nanotechnology and what is nanoparticle. So nanotechnology that deals with dimensions and tolerances of less than 100 nanometer in nano scale. Dimensions and tolerances are less than 100 nanometer in a nano scale, and also is a manipulation of individual atoms and molecules to form a nano material. And these kind of nano material are used to study the nanotechnology, and nanoscience are used to study the nanomaterials and their properties to create a potential application to reshape our entire world. And nanoparticle that include chemical composition, that is include semiconductors, biomolecules, compounds, metal oxides and polymers and carbons, and shape and structure that includes spheres, needles, platelets and tubes, and nanoparticle dispersed in gaseous states, liquid states and also solid state. And origin of nanomaterial is intentionally released and artificially manufactured by humans, and also nanomaterials are already naturally available. And here when we go for nanoparticle, it's a particle size of nanoparticle is very small. That's the nanometer. That is nanoparticle, that is for example fullerene. So fullerene is a allotrope of carbon whose molecule that consists of, so fullerene is allotrope of carbon, that molecule that consists of carbon atoms that connected by a single or double bonds from a closed mesh. So that is called fullerene. So here there is 60 carbon atoms linked together to form a one fullerene unit. So this one unit is 1 nanometer, that is called a fullerene. So here, so for example, that is a buckyball, that this buckyball is a 60 carbon atoms linked together to form a 1 nanometer unit. So buckyball is a hollow cylindrical molecule made up of entirely in a carbon. So here imagine earth, when we ratio of earth and football, so when you see here, so how big of when compared to ratio of earth and football. So at the same way, when we compare to football to fullerene, so there is the ratio of 1 nanometer. So how small when you imagine that. So here, how big a nanometer, how big is a nanometer? So nanometer is a millionth of millimeter or a billionth of meter. So here it's a million times smaller than the smallest measurement you can see in a ruler. So steel ruler, ancient steel ruler. So and also here when we compare to when we consider an practical example, day-to-day life, a human fingernail that grows 1 nanometer in every second. So can you imagine so how nano world is? And also a man's beard grows 5 nanometer per second. So here image taken in a scanning electron microscope or atomic force microscopy, that's a silver nanowire resting on the human hair. So in our human hair, a silver nanowire is resting. So look at a strand of your own hair and imagine how small that is. So that's the nanotechnology deals with. So when we come to nanoscience, that is the study and manipulation of materials at nano scale, that is in the form of nano scale. In the form of nano scale, So what are all the things that happen in a material and their properties and their characteristics that can also change? So in terms of magnetism, size and reactivity, so all strange things happen to materials in the form of nano. In terms of magnetism, smaller particles, so nano means small. So in terms of magnetism, smaller particles can have a different magnetic properties than when compared to larger particles. And also when compared to larger particles in the form of size, when compared to larger particles, smaller particles have a different optical properties. And also colors, for example, colors can change because different sizes of particle reflect and observe the light also, light observability also differently. And in terms of reactivity, when compared to larger particle, smaller particles, they tend to react differently with their environment and when compared to larger particles. So yeah, size is matter. So when we go for, then only we go for nanotechnology and made a material in the form of nano, then we put it into the particular application. So in terms of reactivity, so we have to calculate how the surface volume and how the surface of the cube is calculated, and also we have to necessary to understand the atom, molecule and a nanoparticle and also chemical reaction is. And for example, how, so when we take it in a granulated sugar and sugar cubes, so which dissolve faster? So you can answer this question. And in terms of size, size is a matter when we talk into nanotechnology. So here different sizes of particle that reflect and absorb light in a different manner. So here the color of gold can range from purple to red depending on the size of the cluster of atoms present in the material. So size is an important factor. And nanotechnology is not a newer one, it's an ancient one, because hundred of years ago, and it was known as art. So ancient technology, the ancient days, the humans are doing like this. So here, so now the same technology, when we apply it, that is called, when we call it as a nanotechnology. So here red stained glass gets into color from nanoparticles of gold that are only 20 nanometers across. And also here orange glass gets its color from gold nanoparticles. So gets its color from gold nanoparticles that are 80 nanometers across. So they don't know, but the ancient peoples are using this kind of technology from earlier days itself. So when we come to conclude that what is nanotechnology? So nanotechnology is the development of materials and devices and other components by exploiting the properties of particles, characteristics of particles to the nanoscale by intentionally made by humans, and put it into applications whatever we made in our day-to-day life. So that's called nanotechnology. So what are the impacts on nanotechnology in our day-to-day life? That is in terms of health, diagnostics, cancer treatment and targeted drug delivery. So in each and every activity, all the fields, then nanotechnology is applied. And in terms of material side, in cosmetics, cosmetic, clothing, space elevator, space industry, so all the fields nanotechnology is potentially used. And also in terms of technological area, morphic of computers, and then smaller things, smaller things, miniaturization of materials and more powerful mobile devices and faster processing technologies, all the fields, technological fields. Without nanotechnology we cannot live in future world. And also in the form of environment, when we use nanotechnology we get a better energy storage and also treatment of water and cleaner and energy, we use the nanotechnology. But how this kind of nanotechnology, when we use it, that what made a nanotechnology, and how do we build small things? So in nanotechnology they are using two kind of approaches. That First one is the top-down approach and second one is the bottom-up approach. So in that top-down approach is the maximization, that is macroscopic level to nanotechnology. So macroscopic material are put it into step-by-step process and then they get it into the nano material. And also bottom-up approach means microscopic material, that is nano microscopic materials are using with the some techniques by self-assembling process and then to create a nanomaterial or nano structured component materials. So here computer chips can be made top-down approach, and top-down approach is the building of something by starting with larger component and get it from the material. And also metal wire are made up of the bottom-up material. So what is bottom-up means? So building something by assembling smaller components. So top down is the macroscopic to nanomaterial, and bottom up approach is the microscopic to nanomaterial. And so here nano is the, it's a question of size, that is micro to nano. So what we want to see that indicates the instruments we use. So here carbon nanotube, silver nanoparticle, that is 1 nanometer, 10 nanometer, 1 micron, 10 micron. So here 1 nanometer is DNA, 10 nanometer is the protein, and 100 nanometer we can see it in the virus, and also 1 micron, that is red blood cells or bacteria, and 1 millimeter, that is in our hair. So we use the instruments. So different kinds of instruments, that is atomic force microscopy, scanning electron microscopy, turning electron microscopy, scanning tunneling microscopy. There are so many optical microscope, electron microscope, so many surface analysis techniques are used to characterize the nanomaterials and then study the properties of nanomaterials. So those kind of magnifying glasses, so magnifying microscopes are available to characterize the nanomaterials in our day-to-day life. So these are some images, that is optical microscope, electron microscope, surface analysis, elemental analysis, and so many more things are used to characterize the nanomaterials. That is beyond magnifying glass, we are using atomic force microscopy, scanning electron microscopy, turning electron microscopy, and so on, scanning tunneling microscopy. So these are the techniques are used to characterize the nanoparticles. So with this small introduction, so what is nanotechnology and what are the things you are used to, so how big that is nano is, that is very small, that is in the nano scale, and what are the things used to characterize the nanomaterials. So these are the things we are studied, and nanotechnology deals with the dimensions and tolerances less than in a nano scale, that is 100 nanometer. That is studying the nano materials and their properties to create a potential applications to reshape the world. So that's all about small introduction about nanotechnology. So Jai Hind.